So let's take a look at example number 3. Now, example number 3 I've titled, There's No Such Thing as a Branching Elbow. And by that, we have often had people draw a branch like this so close to something here that it in fact causes, well, what amounts to a branching elbow. And I actually, just before we started this morning, found what I think is a better example here. So here's what I'm going to do. I'm going to bring that on, and this would be an example of how you might see the line drawing. And you can see that right in the middle of the elbow, somebody has drawn, okay, they expect the branch to happen there, right? Well, that really cannot happen. We can't, with a standard piece, do that. Now, if you had to, you could build some kind of special thing. But again, there's a way around this. So if you will, allow me, I'm going to turn that off, the drawing. And what I'm going to do is I'm going to offer the following. We're going to come up and we're going to draw, and we'll use, let's say, 10-inch duct. And we're going to say that that's going there, and pretend that this was that elbow that they were trying to draw their branch from somewhere in there with, say, I don't know, a 4-inch, right? Well, as you can see, that just isn't going to work, right? So let's take a look at how we might fix this. We have to turn the corner, but if we can back up slightly, and even back up slightly here, and then we bring these two together, let's say at a 45-degree angle. And we're going to say that both of these now have 45-degree elbows. Okay. We can now take that 4-inch piece and you can see here, now that works. You've still got the turn and you've got your 4-inch piece, which is essentially in the same position that it was before. So you can see that that would work both for the positioning of their piece of equipment over here, as well as making the right-hand turn without changing where these two trunks really are. The only difference is you're cutting the corner slightly right there, okay? Now, stacking fittings on top of one another, it works as long as you allow for the appropriate space, just like we've mentioned. You cannot merge things into each other without creating some kind of a custom part. And it's very important to remember that some things that are available in galvanized are not available in stainless steel. This goes back to planning again. The same thing is true having to do with different gauges. Some things are available in certain gauges and not available in other gauges, okay? There actually is a machine that has limitations on what it can roll, what it can bend, what it can process. And that is part of how we determine what is available in gauges and in sizes. So here's my kind of final mention about planning. We've often gotten, well, not all that often, we've gotten a few requests for the ability to merge one layout into another. In other words, they've drawn two separate systems that go into the same space, essentially. And they want to bring those two layouts together to combine them. This is fraught with massive complexities as far as the programming of that in a program like DuckQuote. The biggest and probably the easiest to understand is the scaling involved. In other words, in one drawing where the literal distance here is representing, pardon, 6¼ feet or 6 feet and a quarter inch, okay, may not be exactly scaled the same in the second layout. And that's the problem. To be able to merge them, not only must the scaling be exactly the same, and I mean identical, but there has to be some sort of a reference point that is common to both layouts, and the receiving layout has to be large enough that it accepts everything in the two being combined. Well, that really is kind of rare. It's almost never identically scaled, the two. And because of that, we just do not have the merging of two layouts in DuckQuote. Instead, back to planning, if you believe that you're going to be asked to show a combined or full layout, plan to draw it that way. Draw the entire set of layouts all together as a single entity. Then create copies and delete out the parts that don't need to be in that particular copy. That way you've got the combined as well as the individuals, and you can print the individuals as their own orders if you need to, or their own layouts. So that kind of walks you through, why planning is so important. It will save you an immense amount of time if you will sit down and usually it takes less than 5 to 10 minutes to walk through, look at what you have, understand what you're creating, and then plan it out. Okay. Very often in that planning, initial thoughts that you had about how something might be routed, you find better ways. And so it just works to better the entire outcome. Well, that's it for us today. I do want to invite you to tune in next month. We have a advanced class coming up on the 22nd of June, and we're going to have a special speaker, a young lady who's one of our systems engineers who is an expert at reading drawings. And so one of the things that we have noticed folks have a great deal of challenge with is reading drawings, because not always conventions are followed, or how you need to understand what that drawing's trying to tell you about the three-dimensional world into which this is going to fit.